Rhombuses, rectangles, and squares, these are special parallelograms. So when you look at the definition of each of these, notice the rhombus, it says it's a parallelogram with four congruent sides. So first and foremost, all of these are parallelograms. All of them have opposite sides that are parallel. They all have the properties of parallelograms also. So the opposite angles are congruent. The opposite sides are congruent. The consecutive angles are supplementary. The diagonals bisect each other. So because they're parallelograms, they still have all those properties. But then we're going to have some additional things on top of those properties for each of these. Okay, so a rhombus is a parallelogram, so it has all that parallelogram stuff, but it also has four sides that are the same, so four congruent sides. A rectangle is a parallelogram, so again, it has all that parallelogram stuff, but it also has four right angles, so all the angles are the same. And then a square, once again, a square is a parallelogram, so again, it has all that parallelogram stuff, but it also has, in addition to that, four sides that are all the same, and all four angles are the same. So four congruent sides and four right angles, okay? And so each of these, again, is a parallelogram, so it has all the properties of parallelograms, all right? But then we have some additional things that we have to look for on top of it just being a parallelogram. So these are special parallelograms. They're parallelograms with a couple extra properties, with a couple extra pieces to their definition, okay? For example, if I want to classify each of these parallelograms, and notice the directions are saying that they're parallelograms. So we're going to assume that all of these are parallelograms. They're not labeled as parallelograms, but we're going to assume that they are. So assume all these are parallelograms. Let's see what kind of parallelogram they are. Let's see if they're a parallelogram that's a rhombus, a rectangle, or a square. All right? And so if I look at this one, right away, the fact that we're assuming that's a parallelogram tells me a lot of things about this. So using my properties for parallelograms, I know that the opposite sides are the same, so this is 4 meters. I know that this is 9 meters, okay? Using the properties of parallelograms, I know that opposite angles are the same. So right here, this is 90 degrees because the opposite angle is 90 degrees. I also know that consecutive angles are supplementary. In other words, when I add these two angles together, it should equal 180. So if one of them is 90 degrees, well, the other one also has to be 90 degrees. And now using opposite angles again, look at this. This one also has to be 90 degrees. And so just filling this in from the perspective of the properties of parallelograms, I see that this parallelogram is one of my special parallelograms. It's a rectangle because it has four right angles. And we can only classify it as a rectangle because that's the only additional property it has. Okay? When we look at the sides, not all the sides are congruent, so it can't be a rhombus. And for the same reason, it can't be a square. Okay? If I look at this one, once again, if we're assuming that this is a parallelogram, it has to have the properties for parallelograms. So opposite sides have to be congruent. So if this side over here is 6, then this side is 6. If this side down here is 6, then this side up here must also be 6. Okay? And when I look at this, I don't have any information about the angles, so I can't really say anything about the angles. Yeah, I could get my protractor out and measure them, but we can tell that they're not 90 degrees, which is what we're concerned about. And so if I look at this parallelogram, it's one of my special ones. It's a rhombus because all of the sides are the same. So it has all four sides that are the same. But it doesn't have four right angles. So for that reason, it's not a rectangle. And likewise, it's not a square. Okay? If I look at this one, once again, if this is a parallelogram, the opposite sides have to be the same. So if this side is 7, the side over here has to be 7. If this top side is 7, then the bottom side also has to be 7. And then I could go through kind of the same process I did with the first example. I could say, hey, opposite angles are congruent. So that's 90 degrees. Consecutive angles have to add up to 180, so these have to be 90 degrees. And then again, opposite angles. So really, I can really quickly find out that all the angles have to be 90 degrees. So now I have all four sides are the same. All four angles are 90 degrees. That's the square when I look at my special parallelogram. So this one is a square, because it has the properties for a rhombus, all the sides are the same, but it also has the properties for the rectangle, all four right angles. That makes the special parallelogram of a square, okay? And then this last question along those same lines here, a figure is a rhombus and a rectangle. So let's say I had a figure that's a rhombus and a rectangle, so it's automatically a parallelogram then. But if it's a rhombus, all the sides are the same, and it's a rectangle, all the angles are right angles, well, that's describing a square, okay? And so once again, a square is basically a rhombus and a rectangle at the same time. It has all the properties of each, okay?